Okay, so here is a question on Brayton cycle. So let's draw the Brayton cycle in a standard TS diagram, temperature entropy. So first you have a compression, which is isentropic compression. So it's a vertical line, entropy is constant. Then isobaric, that is at constant pressure. Sorry, not isobaric. It's constant pressure heat addition. So isobaric process, yes. And then isentropic expansion in turbine, and then the heat rejection. It depends again on the open turbine cycle or closed turbine cycle, but for our analysis it doesn't matter, we consider it as a heat rejection at constant pressure. So 1 2 3 4. So the max, now come to the problem. Now this max temperature is given and that is at 1300. This is because after the combustion, that is isobaric heat addition, the temperature is max. So this is 1300 Kelvin and this is the maximum temperature. And okay, and these are actually the constant pressure lines. These are constant pressure lines. Okay, so now what is asked is temperature at the end of the expansion process. So 3 4 is isentropic, that is constant entropy, that's why we have drawn vertical line. Okay, so what the temperature, the Kelvin. So T3, so T4 is asked. We know T3, T4 is asked, and only thing we know is that the pressure ratio is given. So how do I relate T3, T4 and pressure ratio? So one thing which you have to keep in mind is that in an isentropic process, just like 3 4, P power gamma is constant, right? And we also assume that it's an ideal gas, so PV is equal to MRT. Now we need to, by the help of these two equations, we need to get a equation between temperature and pressure. Okay, so when I substitute volume from here, so what I get is T power T by P whole power gamma is constant from these two equations. The other way of saying it is that T power gamma okay, is equal to P power gamma minus 1 is equal to constant. The other way of saying it is that when I take okay, T by P power gamma minus 1 by gamma, because gamma, if I take the square root on both sides, so that becomes a constant. So that is it. So this equation is at I mean T by P power gamma minus 1 is constant between this isentropic process. So if I apply between 3 and 4, T3 by P3 gamma minus 1 by gamma is equal to T4, or T3 by T4 is equal to P3 by P4 gamma minus 1 by gamma. So that is the equation. T3 by T4, I have just derived it in case you don't remember, but you are supposed to remember P3 by P4 gamma minus 1 by gamma. So that is P3 by P4 is the compression ratio, which is nothing but 5.5, because 1 bar is that P4 and P3 is 5.5, so 5.5, and specific heat ratio is 1.4, so 1.4 minus 1 by 1.4. okay, and T3 is our 1300 Kelvin by T4 is something it is asked. So from this equation the only unknown is T4, and the T4 value comes out to be, the T4 from this comes out to be 798 Kelvin. Okay, so it's 1300 divided by this, so it's 798 approximately Kelvin. So it's only how do you relate pressure ratio with the temperature ratio in a Brayton cycle. So this question is all about that. So 798 Kelvin is the answer. Thank you.